Welcome students. In this video we're gonna do integration by parts. Specifically we're going to prove. So this is gonna be a proof of integration by parts theorem. So the theorem says that if you have u and b continuous differentiable functions, then if you take the product of uv, it says that if you take the product of uv, that's gonna equal to the integral of course this is gonna be so basically if you have a let's say before I write the whole thing, let's say you have a function that looks something like this: x squared sine x. This is a product, so if you can call this one a function and another function. So the integral of for something like this, you might want to use this theorem, the integration by parts theorem. So the theorem says that if u and b are continuously differentiable, then uv minus b du is equal to u dv. You take the product of uv, the functions uv, minus the integral of v, of the function v, is equal to the integral of u times dv. So that, in order to use such theorem for integrating those kind of integrals, you need to learn how to use this theorem. So right now we're just gonna prove it, okay? So let's say so the proof, okay? Proof. So let u v be continuously differentiable functions. So we're gonna assume that this is on we're talking about an interval. We can call it we can say on AB, but we're not specifying for the proof. I'm not going to specify that. I'm not going to use the an interval. So I'm just proving it for a continuously differentiable function. So let's not use this, but it will be true for this theorem. This will be also true for that, for if you specify it for an interval. Okay, so now if you remember the product rule, so if the function is differentiable, that means that I can take the product of the two functions and I can take the product and take its derivative, since the function is differentiable. Okay, so that means that dx of uv, the derivative of the product, is equal to, using the product rule, is going to be equal to u times dv dx, and then we're going to do plus b times du dx. Okay, the functions are continuous, so that means that by continuity the product, the functions, I can basically, if I call this one 1, the whole thing, the statement 1, by continuity, 1 can be integrated. And then, so we integrate on both sides. That means that the left side, if I take the integral of a derivative, I'm just going to get the function. So it's going to be u times b. And then of course, I'm going to take u dv dx times dx. And then this cancels. And then we're going to do plus the integral of b du dx dx. This cancels. And then so the proof continues here. So now here, and now we okay. So the product is equal to, since that cancels, we're left with u times dv, and then we do plus b times du, and then rearranging. We get that u times dv is equal to u b minus b du, and that's the theorem that we were looking, the final statement we were looking for. So that would be the proof for integration by parts theorem. So first we started with the product rule, then we integrate by the givens that the functions are continuously differentiable. Then we rearrange and we get the final formula for integration by parts. Alright, so thank you very much. Don't forget to subscribe. You help a lot.